Hello everyone, welcome back to my YouTube channel. Today in this video we are going to go through a quick introduction about PyTorch, and in this video we will get the understanding about datasets and data loaders using PyTorch. The best source for PyTorch tutorials is actually the PyTorch website itself. In fact, most of the tutorials I'm going to give today is inspired by the quick start tutorial on PyTorch website. That's it. I hope the comments I am going to make and explanations I am going to provide will help you understanding the fundamentals of PyTorch deeply and will enable you to appreciate the framework the same way I do. One thing I have always loved about PyTorch is its intuitive design. It feels like writing regular Python code while giving you access to powerful deep learning capabilities. Unlike some other frameworks that hide the mechanics behind abstractions, PyTorch lets you peek under the hood and understand what's really happening. So, alright, here we start. So, what is needed to train a PyTorch model? To train a model in PyTorch, you primarily need three things: data, methods to load your data and make it available for PyTorch to consume. This includes loading data from disk or memory, performing any necessary pre-processing, that, for example, converting NumPy arrays to PyTorch tensors, or batching or shuffling, etc. And second thing is model, a class that describes your model structure and forward pass. PyTorch makes it PyTorch makes it convenient by requiring you to define only the forward pass while relying on its built-in gradient tracking for the backward pass. However, if you need to implement a custom function, you will need to define both forward and backward pass logic for that function. Most of the time, the functionalities you need are already implemented in PyTorch. Third, third thing we need is training loop. So this is where everything is stitched together. The training loop involves loading data, using it to train the model, and then calculating the loss function and propagating back to gradients and updating the model parameters. PyTorch flexibility allows you to implement the training loop yourself instead of relying on higher level abstractions like model.fit. This hands-on approach deepens your understanding of deep learning. Before we begin, make sure to install the required packages Torch, Torch Vision and Pandas in your Colab or any IDE you are using. You can install these using pip or Python's package installer. So first of all, data. Two crucial classes you should be familiar with the PyTorch are dataset and data loader. The first class, dataset class, defines your dataset and how to fetch a single row of it, and the data loader class wraps the dataset class and handles batching, shuffling, and utilizing Python's multiprocessing to speed up the data retrieval. From PyTorch documentation, you can say that dataset stores the samples and their corresponding labels, and data loader wraps and iterable around the dataset to enable easy access to the samples. PyTorch also provides a list of built-in datasets to get you started. So let's try dataset classes. We can use the toy dataset that is called fashion amnesty. So we can import torch from torch vision, import datasets, and from torch vision dot transforms, import to tensor, and then we can create training data equal to datasets dot fashion MNIST, and then root is equal to data, root equal to. So this gives this initializes a fashion amnesty dataset, training dataset, where root is equal to data and train is equal to true, and download should be data should be downloaded. So transform is equal to to tensor, and then similarly test data has been created, and we are not going to train the model on this data. So train is equal to false has been set here. This code downloads the fashion MNIST dataset and splits it into training and test data based on the training parameter. The downloaded data is in the pil.image.image data type, but the transform is equal to 2 tensor parameter. This one transform is equal to 2 tensor. This sets the transform is equal to 2 tensor converts it into PyTorch tensors. Fashion MNIST is a simple dataset where each row in the training data represents a single channel image with 28 cross 28 pixels, making the feature vector size 1 cross 28 cross 28. The dataset contains 10 classes labeled from 0 to 9, that is coat, sandal, and etc. So inspecting, now we will inspect the dataset. Inspect the dataset. We can examine some properties of the dataset. Let the data download complete, and then we can continue. As we can see here that download has been completed, and now we will examine the some properties of our training dataset. So let's print training data, training underscore data, and let's see what does it print. So it means that data set is fashion MNIST and number of data points are 60,000, and root location is data, split is equal to train, and standard transform, and transform is equal to 2 tensor. So now we can inspect the first data point, that is print training data, and we can inspect the first data point. As we can see here that it indicates each we can see here that each data point is a tuple of features and labels, and let's examine the like um, each component. So let's examine the each component. So this is the first tensor, and we can also print the shape of this tensor dot shape. So tensor size is 1 cross 28 cross 28, and if we want to print the label of this data point, we can print the label of this data point. So just check it like this. As we can see here that our label of this data point is 9. So in the above example, we used PyTorch built-in Torch Vision dataset for simplicity. You can also create your own dataset class, which is particularly useful for custom datasets such as those in Pandas, data frame, and all. Now, we will explore the lazy loading. Lazy loading. So you might wonder if the fashion MNIST dataset loads all the data into memory. The answer is it does not. Instead, it downloads the image to a directory and performs lazy loading, only loading the image into memory when you access it. That is, for example, when we are accessing training data 0, that means first data point. from the dataset. This is crucial for working with large dataset as it prevents memory exhaustion. So this is one of the PyTorch strength. It is designed to handle datasets that are, too large to fit in memory. Imagine working with a dataset of high resolution images or videos that could easily be hundreds of gigabytes. With lazy loading, you can work with these datasets on even modest hardware. Now, data loader class handles batching and fetching data on a demand from the dataset. We will discuss this in we will discuss about this more in later sections. So your now let's create your own pandas dataset. Now let's create our own pandas dataset. Import torch and from torch dot utils dot data import dataset. Now create a class for data frame dataset where we will pass a dataset and then unit self comma data frame and then feature names and then label names self dot data frame equal to data frame and then self dot feature name is equal to self dot feature name and then comes the and as you can see here that we are setting feature names as feature names from in the dataset and self dot label names as label names, and then we are defining its length as length of self dot data frame, and then if we want to get some item from the data frame, then we can return like then we can define it again like a row is equal to self dot data frame dot iloc and then idx and then features is equal to torch dot tensor we can use and rows and row self dot feature names dot values and for this one values and d type is equal to torch dot float 32 self dot label name comma d type is equal to torch dot float 32. Now it's totally fine, and here we have created a custom a data set. So to create a custom data set details, we will create a like a custom dataset class that involves like um, inheriting the torch.utils.data and like a base class, and then we will initialize an init function to load your data or like a data points to its location, and then underscore len function to like return the dataset size, and then get item underscore get item to fetch one row from your dataset. So the this example accepts a pandas data frame, a list of features, a list of feature column names, and the label column name. This dataset is fully loaded into memory, unlike fashion MNIST, making it suitable for small to medium datasets. For larger datasets, you may need to implement strategies like lazy loading, which is beyond the scope of this video, but might be covered in future videos. So example, now we will create a custom we will create and use a custom dataset. Now let's create and use the dataset. So like we'll just create a new heading and create and use a custom dataset. Now first of all we will import pandas as PD, and then we will define a random data with is equal to um, feature 1 is equal to 1 comma 0 comma 3, and then comes feature 2 feature 2 is equal to maybe 4 comma 5 comma 6, and that's it. And then comes the label for these data points, yes, and that will be 0 comma 1 comma 0. Okay, so that's all for defining a data frame. And now let's create a data frame from this a data set pd dot data frame and then from the data, and let's print the data frame. As we can see here that our data set has two features and one label that has two classes. So we have printed it here, and now let's define features and labels. So feature let's go names is equal to we are defining features and features too, and then label names is equal to label only. So that is it. Okay, and now let's create a data set from mm, from these feature names and the label names, and our data frame is df. And now let's print the data set. Okay, sorry, yes, data frame has no attribute feature names. Okay, actually I think there is a difference between okay, here feature names is equal to feature names, and it should be, where is the problem? Okay, self dot feature names, self dot feature names. Okay, this one, and now let's run it again. Okay, just a minute, just give me okay. So here we have defined the feature names, and then we have defined labels as well. And now let's create the custom dataset using data frame dataset and feature names and label names. Here I have printed length of the custom dataset, and then print the first data point, and then also print the second data point as well. So now let's explore the data loader class for this one. So DataLoader class in PyTorch. Like a data loader class is simply a wrapper around the dataset class. More specifically, it wraps an iterable around the dataset to enable easy access to the samples. So let's dive into some examples and back to the fashion MNIST dataset we declared above. So first of all, we will import a data loader from torch utils.data torch.utils.data dot data import data loader. Yeah, data loader. And then we will define the batch size as well. Batch underscore size is equal to 64. And now we'll create the data loaders. Create data loaders. So we will first create train data loader. Train data loader is equal to data loader, and then we will set training data and then batch size, and then we will we can also set to shuffle is equal to true or false. So we will just set the shuffle is equal to true. And similarly about the test data loader, we have passed the test data and then batch size and then batch for x comma y in test data loader. Test data loader print f shape of we will explain everything later. Just for here I am just writing the code. So let's write the code like of y dot shape, and then comes the and now let's print it. As we can see here that it has printed all the the data training data and test data we created from a fashion MNIST. It has printed NCSW and shape of y as well for all the images available. And since we know each row in the training data corresponds to one single channel image of dimensions 1 cross 28 cross 28 and a single integer level. And so it readily follows that for a batch of 64 images we will have a tensor of shape 64 cross 1 cross 28 cross 28. For the input features, a tensor of shape 64, and for the output levels, notice the shuffle is equal to true parameter in the train data loader, which is meant to shuffle the data in batches. Shuffling training data is common practice meant to ensure that model generalizes well by exposing it to varied data order during training. And the data loader class is an iterable around the fashion MIST dataset. We can loop over it as we do with any iterable, but we cannot access specific index, which is again expected for iterable objects. In fact, if you attempt to do so, you might get a type error. Data loader object is not subscriptable since the dataset object has an internal underscore get item method. The loader will interface natively. The data loader interface natively with this method to fetch a full batch size worth of data. This will become apparent when we talk about the training loop in a a follow-up video. So that data loader class can also interface with the custom datasets like pandas data frame based dataset that we have described earlier, or handling batching or shuffling and other optimization in the same way. So in this way, so In this video, we have covered the fundamentals of data handling in PyTorch, focusing on two essential classes: the dataset class for defining and accessing your data, and dataloader class for efficient batching and iteration. Understanding these handling uh, components is often overlooked in favor of jumping straight to the model building, but proper data management is the foundation of any successful deep learning. And the flexibility PyTorch offers through these classes allows you to work with any type of data and any data format, from simple CSV files to complex multimodal data sets. And one of the most powerful aspects of PyTorch data pipeline is how it scales from simple prototypes to production systems. The same dataset and data loader abstractions work whether you are experimenting on a small dataset locally or processing terabytes of data across multiple GPUs. We explored both, built-in datasets like Fashion MNIST and implementing custom datasets for Pandas data frame. In the second part of this series, we will build model in PyTorch, and in the third video of this series, we will implement the training loop. Stay with us and subscribe for upcoming videos. Do not forget to turn on the bell icon and comment your views on it. Thank you for watching video.